Hello, everyone. Very happy to be here, and thanks for Geoawesomeness and Grey Matter for inviting me today. My name is Ozan. I'm co-founder of Optiyol, a startup in route optimization space. I'll first introduce who we are, what we do, and talk about two use cases in transport optimization. One is a last mile case, and one is a long-haul transportation. I'll mention some points to consider in solution design, and also the here services that we utilized in our solutions. As founders, Tuba and I have a background in operations research and industrial engineering. We have our PhDs from Georgia Tech, and Turan joined us with his software background as a CTO and helps with the software development. And on the algorithm part, we worked on algorithm design, and a team of software engineers build the product. Overall, we are a team of 15 people now and growing. So our goal is to make logistics efficient in terms of cost and on time for consumers. We started in 2015 as a supply chain optimization consultancy and mostly solved strategic level problems such as optimizing the network for ice cream brand of Unilever, where they locate the warehouses, which store should be replenished from which warehouse, and so on. And over time, we pivoted to become a B2B software as a service company focusing on route optimization. We launched the software on AWS Cloud in 2019 with 2 customers. And now currently we reached 26 customers who use our solution in 70 different operations, different cities, and optimize 5 million deliveries annually. And we have a very big pipeline now, which also includes big parcel deliveries. That's why we are looking for optimizing 500 million deliveries for next year as a target. There's a big potential for route optimization. 2 main use cases are transportation of goods and in route optimization, transportation of services. Today, I will focus more on transportation of goods with last mile and long haul route optimization for residential and commercial operations. So what's the motivation? What creates the need for new route planning solutions? One, as Alexander also mentioned, like as consumers, we would like to get direct deliveries, preferably with free shipping and on time and quick, same day or next day. So shippers have the pressure to deliver our items in short times and on time on their promised times with ETAs. They want to reduce their shipping costs to offer free shipping, and they want to gain visibility so that they know where the packages are at any time and make sure their consumers are getting a good service from the carriers. On the carrier side, in the past, they were mostly delivering in B2B space, just delivering to stores, shopping malls, but now with the growth in home delivery, they are now meeting a higher demand, and it's very dynamic, and it's delivering to millions of home addresses every day. So that's a big problem for them to plan. And also to stay competitive, it's a very thin margin industry. They need to reduce their costs. And to offer this visibility, they need to digitalize their operations. Go from like pen and paper to more digital ways of doing business. On the driver's side, there's a huge demand for drivers, and there's a shortage as well, and there's a new generation of drivers. So in the past, like being a driver was a lifetime job, but now people are just doing it for a while after Uber with crowdsourcing. So these drivers need pre-planned routes to spend less time in traffic, and they are compensated by number of packages they deliver. So it's very important to reduce their unnecessary time spent during the day. So consumers and drivers are the beneficiaries, as Optiyol, our customers are shippers and carriers. The route planning responsibility is sometimes on the carriers. Sometimes shippers have the power to plan the routes and share with the carriers that they want these routes to be completed. They want to have access to the software for visibility. The first example is a last mile customer case. Horoz Logistics is a residential big box delivery company with 34 distribution centers in Turkey. They deliver big items like TVs, refrigerators, furniture, sports equipment, and so on. So they approached us with the problem that, again, there's a very dynamic demand. They have difficulty to automate processes. It really relies on experienced planners. So first of all, they wanted an automated solution. Also, demand responsive planning, which means just enough number of trucks planned for that day so that they can reduce their fleet, rental costs, driver costs, also optimize the routes, not leave it to the driver so that they can have a lower fuel cost. Also, their customers have preferences in terms of time, so they want to make sure with an advanced planning that people will receive their goods on their preferred time slots. So we started working with them. So taking a closer look to their world, for example, a planner is faced with a picture like this on a daily basis. So in this picture, there are 600 orders from different parts of the city at different sizes with different time preferences and a pool of trucks. So the first thing to do is to determine how many trucks will be needed for that day and what type, because they have different features. So in this example, the algorithm suggested, for example, 32 routes and how to allocate these orders to each vehicle. Each color shows an assignment to a different truck. And for each truck, since these are multi-stop routes, we need to also optimize the visit sequence. And this visit sequence is not just the shortest path, because you also want to make sure if this customer wanted an afternoon delivery, then you cannot place that customer at the beginning of the route, although it's a shorter route. So you need to be also responsive of the time constraints. So what kind of input is going into the algorithms? Data about orders, data about vehicles, and some business rules and preferences. So for orders, we need to know their pickup locations, delivery locations, to account for vehicle capacity, the order sizes, and some time windows. For example, there can be a restriction that you can only pick up the item between 9 to 11 a.m. in the morning, and you need to deliver by, let's say, 4 p.m. And how much time it takes to pick up the item, how much time it takes to deliver, because you can get estimated traffic travel time data from Here API, for example, but you also need to know how much time the driver will spend at the customer sites for pickup or deliveries. In some cases, they work with dedicated vehicles, so a fixed vehicle can be assigned to the order, but still you need to optimize the sequence of the visit. For vehicles, the vehicle type, whether it's a big truck, van, or a car, their start location, where they start at the beginning of the route. For example, if you re-optimize during the day, then you need to get the real-time location of the vehicle to plan the rest of the day. End location, when they are done with their deliveries, do they come back to the warehouse, go home, or are we just planning one way to the final location that's assigned to this vehicle? It's really important, for example, if they are going back home at the evening and you have that data, it's more likely that they will be assigned packages in their neighborhood, and these locations will be placed at the end of the route, which will be more efficient. Vehicle capacity in terms of volume, weight, number of pallets, number of boxes, or number of stops that they can make during the day. The working hours, what time they can start their route, what time they need to be done. Some information about their costs. There can be some fixed costs. Even if you assign a single order, you will pay the daily rental or daily wage of the driver. And some variable costs about cost per kilometer or cost per hour. And if you add the flexibility, overtime cost. So rules are also very important because, as mentioned, for example, if you are delivering ice cream, you need to have the right temperature in the vehicle. Also, there are constraints between vehicles and locations. For example, in city centers, you cannot send big trucks. You can only allow to deliver with small vans or bicycles, maybe. And there may be rules between different order types. For example, you may not be allowed to carry chemicals and food in the same truck. And some other preferences about traffic, some road preferences or restrictions. So all these inputs go into an algorithm, and optimized plans are calculated. And what's the value of this optimization? There are two examples here where we compare the existing routes of the client with the optimization suggestion. In the first example, we see that the optimization result is 5% more efficient in terms of reducing number of vehicles, and it can reduce total distance by 17%. In the second scenario, with a bigger pool of orders, we can see that the fleet saving can go up to 10% and distance saving up to 19%. And in this one, we also compared the on-time performance based on the existing planning methods, how many orders are delivered at the preferred time slots versus the optimized plan. The second case is for a long-haul transportation example. Tadım is a dried nuts producer and distributor. They have distributors in different cities in Turkey, which is a wide area, 1,500 kilometers from west to east and 500 kilometers from north to south. And they were looking to automate their manual process. A planner was spending hours to do these routes every day. They observed that they were not utilizing this big trucks capacity very well, and they wanted to reduce their transportation cost. So in long-haul operations, there's a slight difference with last mile. Generally, this is outsourced to third-party logistic providers, but still these shippers can do the planning themselves. Either you can acquire and pay for the price of a full truck, and whether or not you fill it, either 10% or 99% or 100%, you pay the same price. That's FTL, but it doesn't make sense to pay the full cost of the truck if you cannot fill it. Then you have the option of less than truckload. In that case, your products are combined with the products of other companies and sent, and you pay per piece as if like you are sending a letter or package with a parcel delivery company. So the first expectation from optimization is to decide which orders should go in full truckloads, which orders should go in less than truckload. The second decision expected is dispatch date selection. So these are multi-day routes, long distances, and the longer you wait for dispatch, there's more possibility to consolidate with other orders going to the same city or nearby cities. So you have better utilization. But if you delay more, you also take a risk that the customers who ordered early, they may have a delay in receiving their packages. So it's important to optimize when to dispatch the trucks, how long you need to wait. Also for full truckloads that you decided, you still need to do a route optimization. So which orders should be grouped together, again, respecting vehicle capacities and with minimum cost of the route. This pick-up and drop-off sequence of these full truckloads. In terms of inputs, the data is similar for orders and rules. Because you outsource the operation now, you're actually procuring resources. You have price list for FTL, you have price list for LTL, and very complex formulations on how to calculate this full truckload cost. So this price list go as an input to the optimizer, and the optimizer tries to find the cheapest way of distributing all these orders for that day. And here is a case study where 414 orders, this was from like a tire company. So they paid 78,000 to deliver these 414 orders in the long-haul routes with FTL and LTL. And we showed that with optimization, they can actually save 20% in a single day, make these savings. So far, we talked about planning. Now, what about the execution? So for execution, we build a driver app. When drivers log into the app with their IDs, they receive the routes that's assigned to them. They can see it on the map, and they can see as a list. From the list, they can follow the routes as suggested. When they pick an order, they get more details. When they click navigation, they are directed to navigation screen. When they arrive to a location, they log their arrival. When they are done, they do the completion by some proof of delivery operations like signatures, notes, photos. They also have a barcode support to make sure they are delivering the right package to the right person. And these drivers can be tracked centrally. We can track both their live locations, and we can see planned versus actual routes on the map side by side. We can see the status of each order. Green ones are completed, yellows are awaiting. And for completed orders, what time the arrival happened, what time the order was completed, how many tasks are remaining, can be tracked. On the consumer side, you can also create like a tracking page for consumers so they can see the status of their order. And also, optionally, they can also make it visible to the consumers. They can show the live location of the truck and the home address. So similar to calling an Uber app, they can see actual real-time status of their package. How we serve our users is two ways. One is API users. So these API users just access, similar to here, like tour planning API, they just access our API without any user interface, just post their inputs in JSON and then get back in JSON format. Some users we call like end-to-end route optimization and tracking solution. They run the optimization either through API or by uploading files, and they get results. They can view on the map. They can make manual changes on the map and share the final plans with their drivers. Driver app is used, and they can track. And then the last one is consumers can also see this process. So what makes it work? Actually, in theory, like there are many algorithms, many papers. Also, when I was studying in PhD, we already thought that this route optimization problem might be already solved, and why still there's a need for it. We saw that there are actually some gaps. There are many real-world constraints and preferences which are not accounted for in classical algorithms. So first thing we had to work on is a comprehensive data model so that we can capture all these rules, preferences, and then incorporate it to algorithms. So if you cannot introduce these things to your algorithms, they will not be aware, and then they will ignore those things, and at the end, these people will return back to their manual planning. It has to be tailor-fit because there are also different preferences. The algorithm should be able to generate alternative solutions even with the same exact data. The third thing we observed is multiple stakeholder view. The route plan should differ based on the perspective, whether you are doing this optimization for a carrier who is interested in real fuel costs, like hard costs of acquiring the truck and others, or whether you are doing it for a shipper who is only interested in how much at the end he will pay. Maybe he's paying per package or some other parameters. You need to optimize accordingly. And the fourth thing is we saw that people struggle with providing right input to the optimizer. For example, a required input is how much time it will take to deliver a package. Is it 3 minutes, 5 minutes, or 20 minutes? Generally, customers, they give just an average number of, let's say, 10 minutes per delivery, which is not accurate because in some places you can deliver very quickly. It's easy to park the car. There's no security and others, but in some places it really takes a long time. So the self-learning mechanism is processing the data from the mobile app or vehicle tracking data and being able to predict the right delivery times. So this really makes the ETAs more accurate. And if you look at the tracking data, maybe 2 hours is spent for driving, but 7 hours is actually spent on customer side for delivery. So that's a bigger part of the day. And there's not a third-party API where you can query this delivery time. So you need to really learn it from your own historical data. And finally, the here services we utilized are here SDK. We use it for our mobile application development in iOS and Android. We use here geocoding services if the customers cannot provide let alone themselves. And here routing services for route calculations, and most importantly, the matrix routing API. So if you are routing for 1,000 locations, you need to have a matrix of 1,000 by 1,000 so that the algorithm will know that if it picks any pair of 2 locations, what will be the distance, travel time, and distance between those pairs. And thank you for listening. And if you have any additional questions, you can reach me through my email. Thank you.